Okay, so what if an AI agent could do more than just, follow a script? What if it could actually think, adapt, and even fix its own mistakes? Well, today we're diving into a framework that's making that a reality. It's called LangGraph.
But before we get into the solution, let's talk about the problem. You've probably felt this, right? Why does so many AI agents, even the really powerful ones, feel so fragile? Like you give them a complex, multi-step task, and they just kind of fall apart.
Well, a lot of it comes down to how they're built. See, most AI workflows are like these rigid assembly lines. They're great for one simple thing, step by step, but they just can't adapt. What we really need is something more like a dynamic workshop, A place where different specialists can loop back, work together, and actually refine what they're doing.
So to really get why this new workshop model is such a big deal, we've got to first understand the limits of that old assembly line.
All right, so traditional frameworks like the Lang Chain Expression Language, you'll see it called LCEL, they're actually fantastic for simple, straight-line tasks, no doubt about it. But the real world is messy, right? Complex problems need loops, they need memory, and they need the ability to self-correct. And that's exactly where these linear chains just hit a wall.
And if you look here, the real game changer is the control flow. In a linear model, the path is kind of hidden and totally inflexible. LangGraph, on the other hand, makes that flow explicit. You can see it, you can manage it. And that one change, that's what takes this from just a tool for simple prototypes to a full-blown framework for building durable, production-ready AI.
Okay, so this brings us right to the solution. Let's talk about this new blueprint for building intelligent agents. Let's talk about LangGraph.
And I really want to stress this. This isn't just some minor update. It's a totally fundamental shift in thinking. We're literally leaving that assembly line behind and stepping into this dynamic workshop we've been talking about, a place where agents can work in cycles and constantly improve what they're doing.
So, at its absolute core, LangGraph treats AI agents as something called state machines. Now, what does that mean? It just means it creates this really clean separation between the agent's logic, that's the what it does, and the control flow, that's where it goes next. And that separation, that's the secret sauce. That's the key to all its flexibility and power.
So how does this whole engine actually work under the hood? Let's break it down. We're going to look at the core components that make this whole new architecture tick.
It all comes down to three simple but super powerful pillars. You've got state, nodes, and edges. If you can get your head around these three concepts, you've basically understood LangGraph.
Okay, first up is the state. The easiest way to think about this is like the central whiteboard in our workshop. Seriously, it's the shared memory. Every single piece of data, every message, every result gets written down right there for all the other agents to see. It is the single source of truth for the entire project.
Next up, we've got the nodes. And these are your specialist workers. Think of it like this. One node might be a researcher, another one's an editor, and another one's a planner. Each node is just a function that does one specific focused task. They're the doers in the system.
And finally, we have the edges. So if the nodes are the workers, think of the edges as the manager, or maybe the foreman of the workshop. They're the ones who look at that central whiteboard, the state, and decide, okay, who gets this task next? This is what makes all those powerful loops and decision points actually possible.
Okay, so we've got our workers and we've got our manager. But a really important question comes up. How do you make sure that when one worker hands a task off to another, nothing gets lost in translation? How do you guarantee that handoff is totally reliable?
The answer is this really clever little thing called the command object. It makes the handoff atomic. And all that means is that the state update, writing on the whiteboard, and the next step instruction happen at the exact same time in one single unbreakable transaction. This is huge because it prevents the system from ever getting confused or out of sync.
And what's great is that the command object is beautifully simple. It just has two parts. You've got goto, which is basically just saying, okay, send this to the next worker. And then you've got update, which is the new information to write on the whiteboard. That simple structure is what prevents all sorts of errors and makes sure every agent is always working with the latest info.
All right, so now that we've got the mechanics down, let's look at the really cool stuff this enables. We can finally move beyond just single agents and start building whole collaborative teams of AI. And one of the most powerful ways to use this is something called the Supervisor Pattern. The idea here is instead of building one giant do-it-all agent, you create a team of specialists. You might have a researcher AI, a coder AI, an editor AI, and they're all managed by one central supervisor node.
So here's how that workflow plays out. The supervisor gets a goal, and it says, okay, this first part is for the researcher, so it routes the task there. The researcher does its thing, finishes its task, and writes the results on our shared whiteboard. Then the supervisor looks at the new state of the whiteboard and says, great, now this needs to go to the editor. And this creates this amazing refinement loop that just keeps going until the goal is perfectly met.
And this is so important. This architecture also makes it super easy to have a human in the loop. You can literally design a node whose only job is to pause the whole process and wait for a person to weigh in. This means the system can stop, ask for your approval on some high-stakes decision, and then, once you give it the green light, it continues exactly where it left off. No starting over.
Okay, so let's pull this all together. Why is this graph-based approach such a massive game changer when you're trying to build serious production-level AI?
Well, it really boils down to 3 huge benefits for production AI. First up, durability. What happens if the system crashes? No big deal. It can just resume from its last saved state. Second, observability. How on earth do you debug something this complex? Well, you can literally watch the agent's thinking process step by step. And finally, scalability. Need to speed things up? Easy. You just run multiple specialist nodes in parallel.
There's a line from the source material that just sums this up perfectly. It says, LangGraph transforms complex cognition into a series of auditable, deterministic transactions. What does that really mean? It means it takes the messy, kind of chaotic process of AI thinking and makes it reliable, predictable, and traceable.
And that leaves us with one last really fascinating thought to chew on. Now that we have a framework that lets an AI build, test, and correct its own work all in a reliable loop, what does that unlock? I mean, really, what comes next?